All right. Hey guys, to this wonderful, wonderful Thursday morning. Absolutely gorgeous outside. So, what better day than to do some geometry work? That's right. You got a problem set today because it is Thursday, our asynchronous day. So, that's when we try problems from the book. And as a reminder, we do have this schedule on Google Classroom. You can always check it out to see what problems you have. And sometimes I put ones that are coming up, even though I don't have it here. So, anyways, here are all your homework problems you're doing today. I'm just going to do 4 of them today. Just things that maybe I thought would trip you up and maybe you might have questions on right now. Here are the 4 problems up here, and let's get started with number 12 from the classroom exercises. Okay, let's go ahead and read this one together. Alan tried to prove postulate 10 as shown below. Ooh, what's postulate 10? I don't know. That's why I don't use the postulate numbers. Anyways, we'll read what postulate 10 is a little bit later. However, he did not have a valid proof. Explain why not. If 2 parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, so that's what he's trying to prove here. He's trying to prove if 2 parallel lines are cut by a transversal, then corresponding angles are congruent. So you remember in this section here, we had to start with one assumption, right? We had to start with one assumption. That was postulate 10. So this was here originally an assumption. Okay, so this actually is here postulate 10. And we have to start with this as an assumption. And then remember, the reason why we had to use this as an assumption is because there's no way to prove it. Right? There's actually no way to prove this statement given the stuff that we had before section 2.2 earlier. So we make it a postulate because it's something that the early Greeks noticed. It's something that a whole bunch of people just notice this here. If we have 2 lines that are parallel to one another, right? Parallel to one another, it's cut by a transversal, then that angle is going to be congruent to that angle. And we're just having that through observation. Can we write a two-column proof proving it? Well, Alan thinks potentially we can, right? Alan thinks potentially we can, but the reality of it is that we can't, and let's maybe look into it. I maybe circled the reason why we can't actually turn this from a postulate to a theorem. Remember, a theorem is a proven statement, a proven fact. We write a proof for it. If we can't write a proof for it, but we still want to say it's 100% true, we know it's going to be true, then it's got to have to be a postulate here. So anyways, let's take a look at his proof here. So here he's trying to prove this. If 2 parallel lines are cut by a transversal. So here, right, this is our given premises here. If K is parallel to L and T cuts K and L, that's everything that's in his if hypothesis here. If 2 parallel lines are cut by a transversal, cool, we get the parallel lines, we get the transversal, there we go. Then corresponding angles are congruent. Then what we can establish, right, by this postulate is that angle 1 congruent to angle 2, right? Those are our corresponding angles. So I'll put a little question mark here because the question is, can we turn this from a postulate into a theorem? Start with this. Can we end with that? And can we end with that as a fact, as a proven fact, as a theorem? So let's check out his reasoning here, okay? All right, step 1, just like with most proofs, right? 90% of the time, step 1, you're stating your given premises, right? If this is true, so we might as well assume this is true. If this is true, it's given to us by the math gods. If this is true, right? If this is true about this diagram, we get parallel lines here, cut by transversal, that's given. Then, right, then can we say this? So he's saying then we can say, well, can't we just say that angle 1, oops, sorry, not angle 1. Can't we just say that angle 2, which is right here, isn't it congruent to angle 3, right? Because what types of angles are those? Those are alternate interior angles. So what he's saying is, because this is true by our given premise, then I should be able to assert this, right? We got parallel lines cut by a transversal, and that's going to create congruent alternate interior angles, 2 and 3, 2 and 3. So I have this circled here. This is a reason. And at this point here, guys, this is where the problem is here. So the question is maybe this: why is this a problem? A problem of why he's using step 2 to justify this statement right here. Okay, this statement right here. And for this, you kind of have to remember about, well, do you remember how this theorem got proven yesterday in yesterday's video lesson? Let's maybe check the book, because I think the book actually proves this for you here a little bit above here. Let's check it out. Maybe you'll kind of notice it here if you're having trouble with this. Yeah, here it is right here. Here's a theorem. This is the theorem that he wants to use in the proof of postulate 10, right? Trying to prove it, right? Trying to make it a theorem here. If 2 parallel lines are cut by transversal, then corresponding angles are congruent. Here's a theorem here. If 2 parallel lines are cut by a transversal, then alternate interior angles are congruent. So, right, he wants to use this theorem that he wants to just say this. He wants to use this as a theorem. That angle 1 and angle 2, we'd have to know that those are congruent here. Let's maybe look into see how this proposition here, right, this if-then statement got proven as a fact, and maybe look down to it. And what do we notice? What do we notice here? Okay, let's see here. All right, so we started with parallel lines. We have transversal. Angle 1 and 3 are congruent by vertical angles congruent. We're allowed to say that. Angle 3 is congruent to angle 2. Oh, interesting. Angle 3 is congruent to angle 2 by reason of if two parallel lines are cut by a transversal, then corresponding angles are congruent. How do we know this? Why were we able to prove this alternate interior angles thing was a theorem? Well, we had to use what in step 3? We had to use this postulate up here, okay? This postulate up here was necessary, okay? So by assuming something, they said this earlier, we have to accept something as a postulate in this book. So we accepted postulate 10 as a rule, right? A rule that we're gonna know is true because it's just obvious, everybody accepts it as true. And then we use postulate 10 to prove this theorem here, that if two parallel lines are cut by a transversal, then alternate interior angles are congruent. Look, it's right here. That's part of our justification of why this is a fact right here, okay? So perhaps you realize this, right? And a red flag really should be coming up in your head right now, in that the only reason why this is a fact, we consider this to be a theorem, is because we proved it using the postulate, using the corresponding angles postulate, where if you have parallel lines cut by a transversal, then corresponding angles are congruent. So then the question is, if we use the postulate to establish this as a theorem, are we allowed to then use this theorem to go back to the postulate and then prove it as a theorem? And the answer to that, you should know this, you should have a feeling about this right now. The answer to that is no, That's actually something called circular reasoning. You'll be studying that, right? If you take logic classes in college, if you follow up with some of this stuff, and in computer science, right, circular logic and circular coding comes up all the time. But if you have something like a postulate, and we got to use that postulate to get to this next theorem, right? To get to this next theorem, you can't then go back and then use that theorem. We use the postulate, right? We use the postulate to get to the theorem. We can't go backwards to then use that theorem to prove the postulate is fact, because then we're going in a circle. That's circular reasoning. We don't have appropriate justifications. We only have appropriate justifications going one way, right? Going one way. So that's why we call proofs and theorems, we call it a chain of reasoning that, okay, I have to make this assumption. That's going to get me to this fact. And then I'm going to use that fact to prove other facts beyond that. We can't go backwards and say that thing that we proved is a fact using that rule. Let's use that to then prove the rule that we used to prove the facts, because then we're just going in circles. Something called circular reasoning. And you don't have to know exactly what that is, but you have to have kind of an idea about that and looking out for it in the future, okay? So let's go ahead and write the answer in here. His proof is not valid because he uses a theorem that required postulate 10. I'll just write postulate 10 here. I don't like writing the numbers, but I'm just trying to get this a little bit faster. Required postulate 10 in order to prove that theorem. Okay, he cannot use future theorems. I like to call them future theorems to prove older postulates, right? Older postulates, because that's something called circular reasoning, okay? So that's one thing that I'm already reminded a few people about who maybe have studied this a little bit before, maybe looked up answers online, that the things that we're going to use to justify in the future rely upon the things we're studying right now. So we can't justify things that we haven't proven yet. Or things that prove in the later. So stuff in order, right? That's why we do this book in order here, right? So we can't use things that haven't been proven yet in justifications of stuff we're talking about right now, because could lead to a circular reasoning fallacy, which we want to kind of avoid. Okay. Anyways, that one's something to think about, because I want to be pointing out to people, hey, we haven't learned this theorem yet. We can't use that to justify things we're talking about right now. We need to kind of go in order and avoid circular reasoning. All right, the next one should be a little bit more quick here. This is just kind of a warning question right now, and something to stay away from, and we'll practice that in the future. So quicker questions here. Here we got some algebra problems solving for x x and y. Excellent. So if you've done a lot of algebra, you should be in good shape. If you've done a little bit less algebra, let's do it together. Let's figure it out. All right, okie dokie. We got some parallel lines right here. So these are the two parallel lines. So this must be the transversal right here, because this is the only line that connects those two parallel lines. So that's our transversal. That could help us out in this problem. So here, what I'm going to do is I'm going to mark up what I know is congruent. So for instance, this here, x and y are actually going to be corresponding angles, because we have our two lines cut by the transversal. So these are corresponding angles. Those are congruent. So I know that x is going to equal y, so we'll get the same answers for both. That's nice. What's some other pieces of information I can pull out here? Well, this is 110 degrees. Ooh, this is congruent to this. These are vertical angles. So this is 110 degrees. And that'll be helpful because what we know here, I'm going to do this in green. I know it's getting messy. We know that these three angles add up together to become like kind of a straight angle, right? Which measures 180 degrees here. Look, this is just a line right now. So boom plus boom, boom plus boom equals 180 degrees, those three measurements here. So what I'm going to do is I'm going to take, to solve my first variable, I'm going to take 30 plus 110 plus y, because this angle plus that angle plus that angle adds up to a straight line, which has 180 degrees on either side. So that's going to equal 180. And now I just need to solve for y. Combine like terms here. We get 140 plus y equals 180. Isolate y, subtract 140 from both sides. And we got y equals 40. And because we know this up here, x equals y, that also means that x is going to equal 40. And we got our answer. So you have to play with these ones and get little puzzles. I don't know if I chose one of the harder ones for you guys or one of the easier ones for you guys. But anyways, you have an example. That's the kind of thing you have to do. Find the corresponding angles. Find the alternate interior angles. Mark them up. Where can we find things that add to 180? Get that in the problem, right? That's kind of the approach. So you'll be able to review that a bit with your group tomorrow when we do homework review. Number 13. Okay, number 13. I want to do number 13 and number 17 because I want to do one of the proofs with you guys, one of the free-form proofs with you guys, just to see it's not that bad, right? Get the ideas down. Talk about those things that we're doing in section 1A in terms of working backwards, in terms of drawing a diagram out, in terms of just coming up with a game plan. So number 13, I think, is good. These fill-in-the-blank ones are good because they're going to give you a preview of a lot of the reasons you're going to use in the proofs at the end of a homework problem set here, okay? So here it just says write the reasons. So here is sort of decoding what are the reasons that are in this section, right, that we use in this section that we might be having to use for the first or second time all year, right, because they're just brand new. And then what are some of the older things that we need to practice as well? That's why we have problems like that. So here, 90% of the time we start with given, and I noticed this, given K is parallel to L, and I have that right there. So that's my given premise. So we'll put given up here. Okay. Then, right, what I don't like about fill-in-the-blank proofs is that a lot of times you're not thinking backwards. They're just sort of like saying random stuff. This is kind of weird. So maybe just take a second trying to figure out what it is they're trying to prove. They're trying to prove that angle 6 and angle 7 add to 180. Okay, add to 180. So maybe you're just kind of thinking through your head, how would I justify that these would add to 180? Well, these are parallel lines. That's nice. It gives us parallel lines. We would know that 6 plus 8, right? 6 plus 8 are congruent. Those are congruent to one another. That could help. And then 8 and 7 are supplementary, right? And 7 and 5 are congruent. I don't know. There's a whole bunch of stuff you can say. So maybe 6 and 8 are congruent, and these are supplementary. So let's see here. Supplementary to that. 6 is congruent to 8. That's supplementary. I think we can figure this out. Anyways, it'd be harder to prove kind of on our own. Let's see what they say here. All right. Anyways, 6 is congruent to 8. How do we justify that? Those are indeed going to be corresponding angles. So they're in the top right. They're in the same position of this whole thing with the transversal and the two parallel lines here. These are corresponding angles. So we're going to do that if, and you got to write it out, guys, if two parallel lines, oops, I want a text box here. Boom. Get rid of it. If two parallel lines, nope, where's it going? I want this. There we go. Two parallel lines cut by a transversal, then corresponding angles are congruent. And we're good to go with number 2. Okay, next up, they say this. They say measure angle 8 plus measure angle 7 equals 180. How are we doing that for this here? What do we have? Guys, what is angle 7 plus measure angle 8? It adds to 180, yeah, but how do we justify that? Why do we know it adds to 180? Well, they make up a straight angle. So this is part plus part equals whole. right? The parts of a straight angle add to 180. That's the angle addition postulate, okay? Remember, angle addition postulate can be part plus part equals whole, and that whole could be not a straight angle, so we're just saying the measure of that large angle. But if it is a straight angle here, look, this is a straight angle right here. It adds up to this whole line. We would say angle addition postulate as well. We just replace that straight angle name with 180 degrees. So that's angle addition postulate. All right, next up, we're making another statement about 180, okay? Another statement about 180. So measure of angle 6 plus measure of angle 7 equals 180. And that looks like, so 7, 6, those aren't like same side interior. They're same side exterior, that's true. But they're not, we don't have a theorem for same side exterior angles, 6 and 7. So there's got to be some other way that we proved this statement for here, okay? How do we do that? We had 180 in this original equation right here. So the only thing that changed right here, remember, when just like one term changes of an equation, it's oftentimes going to be substitution. So let's check it out here. What are the two things that changed? You got to think, how did my equation change? Well, it changed from measure of angle 8, it changed to measure of angle 6. Why are we allowed to do that? Look at step 2. Measure of angle 6 equals measure of angle 8. So what we did is we took measure of angle 6 and we replaced measure of angle 8 with measure of angle 6, and that's why we have this down here. So this one is the substitution property of equality, okay? So that's the one where you think, properties of equality, you think, how did my equation change from one step to another? And how would I justify it? It changed from step 3 to step 4 because we put the information from step 2 into step 3, and we got that equation as the result here. This here, measure of angle 6 plus measure of angle 7 equals 180. And when the measures of two angles add up to 180, they can get classified as something. Remember, the two angles that can get classified as something, this is here, right? Getting from this step to this step is, we're just asserting that we know what supplementary angles are. So this is the definition of supplementary angles. So supplementary angles are angles whose measurements add up to 180. That's how they're defined. That's how we identify them. That's how we classify them. So that's what they are. Not any facts beyond that, just what they are. They add to 180. Cool. We're using the definition of supplementary angles there, and we got this proof figured out. So hopefully you watch that and listen to it, because even I'm having trouble reading my handwriting on that one. All right, number 17. This is one of the free-form proofs you got to do. You got to do 3 of them tonight. This isn't that bad, though. I'll see if I can get this done in less than 5 minutes. Spend 3 or 4 minutes on this one. Always when you get to a proof, got to copy down the given statements. Got to copy down the diagram. I'm skipping that just so I can show this video really quickly, but I got to see all this, right, when you turn it in, because this helps you get unstuck. Because as you're writing down this, you're thinking, ooh, I know what I'm starting with, okay? So I'm probably going to start with this K is parallel to L, but I'm also thinking, hey, I'm probably going to have a transversal in my diagram, okay? Grid paper makes this a lot more organized because you can draw your 2 columns a little bit better. That's why I'm always keeping hammering home. Get your graph paper, get it. So I'm just going to jam in. There's no harm in jamming in the given statements, given premises here if we think we have a useful one. And we do, because these 2 lines are parallel to one another. Then our goal for this is, what do we want to do? We want to say that angle 2 and angle 7, so these are alternate exterior angles. Interesting. We're proving that alternate exterior angles would also have to be congruent to one another, which sure could be a theorem once we prove it. But we don't save that in our minds. And in the textbook, they save space. They don't make this a theorem. So that's one thing to point out this year, is that you'll be proving facts in your homework. Whenever you have a proof in your homework, you're proving a fact. But you don't have to memorize those facts if you don't want to, right? Because they're not the important theorems that your book is pointing out to you. The book has like over 100 theorems we'll use this year. They don't want to have this be another theorem you have to memorize and use. So anyways, you can actually use this if you want in a proof, and I'm always impressed when students do. It's great. So if we, again, just to remind you guys what we're looking at here, if we have 2 parallel lines cut by a transversal, then alternate exterior angles. Here, there's an alternate sides of the transversal and the exterior of the 2 lines. These would be alternate exterior angles, and they're going to be proving congruent. We're going to do that together right now. So we want to get to this, okay, 2 and 7. So maybe we think backwards a little bit here. Well, how do we get 2 and 7? Well, we can start saying things about 7, for instance. 7 is congruent to angle 4. That could help us, right? That could help us. And then 2 is congruent to angle 5. That could help us. That could help us. So one of the reasons why you copy down that diagram, in addition to be a complete proof, is that you can maybe sketch it out, and then, hey, you can maybe notice some things. Like if I just do this and I do this, oops, I need 2 tick marks, I guess, on all these now. It looks like right? We can definitely say those two are congruent here, right? Why can we say that 4 and 5 are congruent? Alternate interior angles, and they're cut by they're parallel lines cut by transversal. And angle 4 and angle 7 are congruent. Why? Because vertical angles are congruent. Vertical angles are congruent. So just by marking it up, you can kind of see how it kind of connects, and it gives you ideas of things to talk about here. Okay, so what I'm going to talk about first, and it might not be the thing that you talk about first, I want to get angle 7 into this proof because that's what we're trying to prove, something about angle 7. And I'm going to get angle 2 into this proof. I'm going to do that by connecting it to their vertical angles here. Here, check this out. So here I get angle 7 into the proof because I can say angle 7 is congruent to angle 4. And I can also say that angle 2, which I also want to get into the proof, is congruent to angle 5. So this is an example of working backwards, which is one of the key things in order to write a proof. You think about the things you need to talk about at the end, figure out a way to start talking about them now in the proof, okay? Look at the end and then get that into the proof because then you can stack your chain of reasoning together and get to the end of the proof here. So if two parallel lines cut by a transversal, then, oh wait, nope, that's actually not necessary. I don't need to do that. This one's a lot quicker than that. So while you're in your exit ticket, they reminded you of this one. Flex this theorem here. Vertical angles are congruent. Again, reminder, this is not the definition of vertical angles. The definition of vertical angles are two non-adjacent angles that were formed by intersecting lines. It says nothing about whether or not they're congruent. We need a theorem for that. Vertical angles are congruent is that theorem in words, okay? So now we got 7 and 4. We're going to connect 4 and 5 right now, right? We want to connect 2 and 7. We can connect 4 and 5, and 4 and 5 are connecting 2 and 7. Very good. We can say that angle 4 is congruent to angle 5. Why can we say that? Why can we say it? Let it flow, baby. Finish this puzzle on out. Let it flow. Let's get this. Here, angle 4 and angle 5, those are alternate interior angles. But why? Remember, not all alternate interior angles are congruent. It's only when you have those two parallel lines. So if two parallel lines are cut by a transversal, then we can make the conclusion that alternate interior angles are congruent, okay? Are congruent. And we did that here, right? If we know that these lines are parallel, transversal, we can say 4 and 5 are congruent to one another by that reason, because they're alternate interior angles cut by transversal parallel lines, right? We got all of it. We got our given premise here. Given premise here was important to conclude that angle 4 and angle 5 have to be congruent. All right, here we go. Continuing moving out here. What does 4 connect to? 4 connects to 7. What does 5 connect to? 5 connects to 2. So this one here, you got a couple reasons that I'd probably accept on this one, but I'm going to give you the trickier one here. We can actually finish this proof right now. Check this one out here. I can write it out the long way, and that's what I'm going to do. I'm going to do this the long way. I can say here, because my goal is I want to say angle 2 is congruent to angle 7, so I'm going to do this kind of spaced apart. Check it out here, what I'm going to put in the middle. So, oops, I need an angle symbol there. So angle 2 is congruent to angle 7. I'm going to get to that in a second. Because angle 2 connects to angle 5, and angle 5 connects to angle 4. And angle 4 connects to, oops, I already had the congruent symbol in there. Connects to, I'll maybe move the congruent symbol a little bit closer here. And angle 4 connects to angle 7. These are congruent. Therefore, angle 2, right? Angle 2 would have to be congruent to angle 7, and we would finish the proof. Step 4 right here, okay? So this is sort of the book tried to give you a little heads up about this earlier here. What do we do here? Well, I'm trying to connect angle 2 and angle 7. Angle 2 is congruent to angle 5, and angle 5 is congruent to angle 4. So here, right, look, this is one thing here. When you have two things that are each congruent to the same thing, then they are congruent to each other. That, my friends, is the transitive property, okay? Transitive property of congruence here, What we also have is this, okay, which is down here. Now, if we wanted to connect angle 5, which is the same as 2, right? We want to connect that 7 here. Check this out here. 5 and 4, so 7 and 4, 7 is congruent to 4, and 4 is congruent to 5. Therefore, we can make the conclusion that 7 is also equal to 5. 7 is also equal to 5, which is equal to 2. So anyways, this is, earlier in the book, people had questions about this, and it is confusing, certainly confusing to kind of figure out here. But this is a situation where your best answer here is transitive property, and the book will do this sometimes too. They'll point it out to you here. They'll say applied twice. That is your best answer for this particular situation right here if you just said this. You don't have to say this whole thing here. You can just say transitive property applied twice. So here we're looking at this diagram, trying to break this one down, not this diagram, the step statements reasons, these statements here. We want to say 2 connects to 7. Well, 2 connects to 5, and 5 connects to 4, so that's transitive once. And then 4 connects to 7, and 5, so 5, 4, 7, that's transitive twice. We can just say 2 would have to connect to 7. If one thing is equal to, it's congruent to another thing, which is congruent to another thing, which is congruent to another thing, it's just one more time we're using transitive in order to get that proof done. And there we have it, folks. We have started with what we were given. We were given parallel lines cut by a transversal, and we were able to prove that alternate exterior angles would have to be congruent to one another. So if you want to use that as a theorem moving forward, you can totally do that, right? We have justified this statement here by starting with a statement, we ending with a statement, we justify it by all this garbage in between, all this justification, all these theorems that we have now. And that's the beauty of this. And that's why we know this is a fact and nobody can argue with this. And that's the very nice thing about this class and what you're learning this year. That's it for me for today. Feel free to email me if you have any questions about these problems or these videos, or you want to learn about any other problems that are in this section. Let me know. Have a great day, guys.